Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Top Right Boy by Sunny K. And here are the rules. We have chaos construction rules, where we need to divide the grid into 9 orthogonally connected 9-cell regions, and place the digits 1 to 9 once in each row, column, and region. What is an orthogonally connected region? It's a region where you can go from any cell in that region to any other cell in that region just by going through edges, all while staying within the region. So, for example, we have this as a valid orthogonally connected region because you can go from any cell in this region to any other cell in this region just by going through edges, all while staying within the region. So, for example, you can go like that way to go here to get to this cell, all while staying within the region. What is an example of an invalid region is something like this. Because these two cells, while they can get to each other by going through edges while staying within the region, cannot get to any of the other cells in the region just by going through edges while staying within the region. They either have to go through a corner and staying within the region, or they have to go through an edge, exit the region, and then go back to the region itself, which is not allowed. So that is how orthogonally connected regions work. We also have top right boy, where in each region, the rightmost cell of its topmost row is a doubler. And the value of a doubler is twice its digit. And digits cannot repeat in top right boys. So, the top in this region is the example region. The rightmost cell of its topmost row is this cell here, and that's a doubler. So this the value of this cell would be doubled. So if we had a 9 here, the value of that would be 9 doubled, right? Which is 18. So that's an example of how top right boys work. Also, again, digits cannot repeat in top right boys. So in all the cells that are the top rightmost cell, first of all, they're all doubled in value for their value, and there are no repeats. They are all unique. So say, for example, this was another region here, then this would be the top right boy for this region, and it would have to be double whatever that digit is. So say it was a 1. Oops, say it was a 1 here. Then this value would be 2. And again, that would work because these two digits are different, because you cannot have repeats in the top right boy cells. So that's how top right boys work. We also have bottom left boy, where in each region, the leftmost cell of its bottommost row is a nullifier. So the value of a nullifier is 0. And again, digits cannot repeat in bottom left boys. So in this region, the bottom left boy would be the leftmost cell of the bottommost row. So it would be this cell here. So whatever this digit was, its value actually would be 0. So that's how bottom left boys work. We have white region dots, where cells joined by a white dot belong to the same region and contain consecutive values. So this is actually not valid because these have to be in the same region. So let's just change this so this is a valid region. So these have to be in the same region because they're connected by a white dot, and they must contain consecutive values. So, for example, since it's not top right boy and it's not bottom left boy, these could just be regular values. So this would be, if this were 6, this would have to be 5 or 7 to make sure that these digits are consecutive. We also have black region dots, where cells joined by a black dot belong to different regions and contain values where one is double the other. So, obviously this doesn't work if this is 9, but say we had a 4 here. then this digit would have to be 2 or 8. And, well, it doesn't work because they're in different regions. So let's basically have that. Say it was a region here. Then these values would have to be in a 1 to 2 ratio. So you could have 4, like, say this was also a top right boy here. Then if this was 4, this would have to be 2 or 8 to maintain the 1 to 2 ratio. This would have a value of 8, and this would have a value of 16 or 4. And they have to be in different regions because the black dot indicates they must be in different regions. And finally, values along an arrow sum to the value in the attached circle. So the values along this arrow is equal to the value in the circle. So all of these values would have to equal the same as this digit here. Or the value of that cell, I should say. And it's the same thing for this. All the values of this column here would have to equal the value of this cell here, etc., etc. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, start off. Let's get the boundary. We know black crop key dots separate regions. So this is going to have to go this way as a region. And this is going to be a top right boy. Then the question is this going to be a top right boy also? And I think the answer is yes. Because if it's not a top right boy, how is that going to work? If it's not a top right boy, this has to go somewhere to a higher row, because this is the rightmost of the second row. So it would have to have, if it's not a top right boy, it would have to go into the first row somehow. But then that would block this region from being a fully fledged region, right? If you try to, any way you get it around, it's just not, there's not going to be enough space, right? 1, 2, 3, 4, 5, I don't even know. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can't go there to get back to get to the first cell. So what happens if you try to do that? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's possible, but then this is, again, only 7 cells. Any other way here, this is only 7 cells, and this is 9 as a row. So this has to be a top right boy also. So they must be in a 1 to 2 ratio. And they're both doubled. Now the question is, what can be bottom left boys? None of these can ever be a bottom left boy. Right? Either they don't go down, either they go down, in which case this is not going to be in the bottom row, or they have to go. Yeah, none of these can be a bottom left boy, because again, either they go down, which means this cell is not in the bottom row, or the region has to continue somewhere to the left. So that is interesting. That means I think this digit has to be an 8. Right? These can never be bottom left boys. The value of the digit is, the value, it doesn't say, does it? I'm assuming the value of a digit, yeah. It doesn't say anything about, normal. But I'm assuming, the value has to be that it's the same. Otherwise, it just doesn't make any sense, right? Then you can't have a value of 0. So the value has to be the digit itself. So that means this must be 1 through 5 there. and this has to be 8 as a value. That's a lot of bottom left boys than we need for these cells. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means one of them is not going to be a bottom left boy. This obviously has to be somewhere. So this is going to be a bottom left boy. But every other cell, every other cell has to be a bottom right boy, bottom left boy. Because this is the digits 1 through 5. It's 15. We have 8 here. We can only have one more value of a 1 in that cell. So if these have to be bottom left boys, you could have this. So what is the bottom left? I guess you could do something like that, right? That is the bottommost, that is the leftmost cell of the bottommost row. So we have to have bottom left cells all along here except for one digit. That's interesting. Obviously, these very well could be bottom left cells. So that means all the bottom left boys are on this arrow. Because again, we have 1 through 5 here guaranteed, and they have to be the value of the digit. That adds up to 15. 8 doubled is 16. So every other value has to be 0 except for 1 that's not. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cells in this area. So this could be a bottom left boy. We could have 9 there. This could be a bottom left boy. That would be 8. If these two are bottom left boys, this cannot be a bottom left boy. Because it's either going to have to go this way, in which case it's going to extend that way, or this is going to be here, but then we don't have enough that's a bottom left boy here. So one of these three cannot be a bottom left boy, which means all of these are bottom left boys? I guess that could work. We have green, yellow. Can make that blue, orange, or not orange, pink. I don't know what these are. Right? Because assuming that these are bottom left boys, that means all the digits in the region this is the bottom left boy in, has to be in one of these cells here. Same with this. So then that counts for 18 cells where this is the bottom left boy and that's the bottom left boy. So we know one of these three cannot be. So we have to have something do like that. Right? So we could have something like this. Or I guess it could be something even like that, potentially. That could be a bottom left boy. So remaining digits in row 1 are 6, 7, and 9. None of these can be doubled. So none of these can be top right boys. So we definitely do not have that. Hmm. Um, right. So one of these threes is not a bottom left boy, right? It could do something like this to be a bottom left boy. But so therefore this is a different region. These are different regions. So this can't be yellow. This is red or green. It cannot be green. This has to be red. Red has to go out this way. Um, this is not going to be a bottom right boy at all. So these digits have to be 1 through 4 at least, so this must be a top right boy. So this is the top right then only for red because we can't go. Okay, well, we don't know that for certain, but this is red here. So whatever goes up here has to basically continue here. But the thing is, so this has to be a top right boy. So we're going to mark those as green. So these have to be top right boys. This is a top right boy. These have to be bottom left boys here. Up to here. We know that for certain. So yellow could go here. Blue cannot, so this is a boundary here. Pink cannot. This cannot. This cannot. Ah. That's an interesting boundary. Um... Hmm. This, therefore, none of these are bottom left boys. So this also must be doubled. So that's doubled also. So this is at least 5. No 8 because it's doubled. This is at least 5. Again, no 8. This has to be 4, right? Doubled. The only value that's going to be in a 1 to 2 ratio with 16 in this puzzle is 8. And it has to be doubled, so then this is a 4. Interesting. So this is either yellow or green. It cannot be red, because if red wraps around green, it's not going to be a full region. So we have yellow or green here. Green has to get past this, because this is green at most 8 here. So green has to go there, which means red does have to go that way. Shoot, that's too few cells for red. These don't have to be green, though. These two do have to be green, but these don't. So we have 1, 2, 3, 4, 5, 6, 7. We need 8, 9. So these are 8 and 9. And that's definite, because this needs to be a top right boy to basically be valid for these 4 digits to add up to this. So that means these are all green. They cannot be yellow. We have 1, 2, 3, 4, 5, 6, 7. This is a different region. So this must go up 8. And we don't know what the rest is. Okay. This is a 1, 2. So this can't be a bottom left boy. So this has to go essentially. It has to connect to something here. Lower. This is done. So yellow has to go out this way. That's 3. That means blue has to go this way to get exit out. That means yellow has to go one more that way. Different region, different region. So pink has to go that way. That means blue must extend that way. Yellow has to extend that way. This has to go that way. We'll make this one orange for now. This is a different region. So that extends pink. That extends blue. That extends yellow. So for this to be a top right boy, we need to have this all be yellow. So that means blue has to go this way. Pink has to go this way. Orange has to go that way. I guess we'll make this light has to go this way. And this has to be a bottom left boy, so this cannot be. Which means these have to be bottom left boys also. So we have boundary here, boundary here. We have 1, 2, 3, 4, 5, 6, 7, 8. We have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 cannot be there. Shoot. 2, 3, 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9. We could have one more dark go that way. This is almost certainly has to go from this way, because otherwise this would have a bottom left boy going this way, or it would be on here, if it were connecting here. So this has to connect to here, because there's no other place to go. It has to go to here. And these are not, these are separate regions. 1, 2, 3, 4, 5. It has to go this way then, which means green has to go here to complete 1, 2, 3, 4, 5, 6, 7, 8, 9. Otherwise, if it doesn't go this way, we try to have another full region. That's not possible, because we need to have a little bottom left boy here. So then that works. Well, we don't even know. It could go out here. So this could go out that way. We have 1, 2, 3, 4. So this could go to here. It could extend to here. One thing we do know is this can't be light. So 1, 2, 3, 4, 5, 6, 7, 8. You could extend there. You cannot go the full 9 that way, because then the bottom left boy would be there. And the bottom left boy so this could be dark or it could be light. We don't know. So that means we have these are all light, guaranteed. 1, 2, 3, 4, 5, 6, 7, 8. And this could be light. We don't know. We know these 7 are dark. It cannot go dark, dark there. So this must be the bottom left boy here. So we have 1, 2, 3, 4, 5, 6, 7, 8. So it could be 9th here, or one of these is 9th. This has to be bottom left boy this route. So, um, you don't know about those. Yellow's done. Blue, we don't know. Pink, we don't know. Orange, we don't know. Um, so we'll make this medium. Medium does have to go out that way. And it cannot ever go down because this is the bottom row for that region. Same with dark, but this could be orange, cannot be pink. Um, we could have 2 digits. Okay. So these are the bottom left boys. Um, hmm. These are going to be medium or dark here. These can never be dark. So these could be medium here. This could potentially be medium here. Dark can be any of these. These cannot be pink. If we try to get pink here, 1, 2, 3, 4, 5, 6, 7, 8, 9. That would work. But these cannot be pink, right? If we tried to cut there, this is only 6 cells as a region. If we try to cut here, that's 10 cells, so that's not going to work. And if we try to cut there, that's 6 cells as a region. So these both must be blue. Um, okay. So none of these are bottom left boys, and none of them are top right boys. So this must be the sum of these. So we have 9 could be the sum of 3 and 6 and 2 and 7, or 7 could be the sum of 1 and 6, or 2. Yeah, it would have to be 1 and 6 if that's the case. Okay. Neither of these are top right boys or bottom left boys, so it's 1, 2, 3, 4, 6, 8 next to it. This either adds up to 10, 12, 14, or 18. So does this 10, 12, 14, or 18. So we have 1, 2, 3, 4, 5, 6, 7 blues. So blue can go 2 more. We don't know where. Pink could go all over the place here. Light, you have 8. So then orange could go all over here. And could go 2 up here. We don't know. Technically, it could do 1, 2, right? No, it can't do 1, 2 because that blocks the medium from... Well, this could be 1, 2. So this could be orange here. Okay. Different digits in the bottom left, boys. Well, we're missing this digit, and this digit. This digit sees all of these bottom left boys, so this digit must be the same as that one. So we're going to mark that with an A. Those are the same. These two then must match these two here, but we don't know which is which. So B and C, this could be B or C, this is B or C. And everything else in the column doesn't repeat, so that's fine. Hmm. For it to be consecutive, we have to have an odd and an even value. So one of them definitely is not a top right boy here. They have to be in the same region, though. Oh, these have to be in the same region. So this cannot be dark, and it cannot be pink, orange here. Pink, potentially 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's the most it can get to. So I was trying to think where it could go here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess that is possible. The thing, you have orange 1, 2, 3, 4, 5, 6, 7, 8, 9 could go that way, right? That's the reasoning why that could be pink here. Pink cannot go here because then that blocks orange from being a full region, which is not allowed. These are the same region. So these are both gray. So again, any dark could be any of these. You could have medium go that way. This cannot be pink, though. We can't reach here for the pink. 2, 3, 4, 5, 6, 7, 8, 9, right? These are the same region. That's interesting. So we know these are gray. Technically, you could have all the gray here, and then this could be... Can this be orange? 1, 2, 3, 4, 5, 6, 7, 8, 9. No, this can't be orange. It has to be gray. Interesting. Okay. Can we have dark here? I think the answer is no. If we have dark here, these become medium gray. 1, 2, 3, 4, 5, 6, but then how do you connect? 7, 8, 9? It can't. Orange can't reach there. 1, 2, 3, 4, 5, 6, 7, 8, 9 is the most it could be. So this cannot be dark. It has to be medium that way. So dark is either here or here or here. You could have all of this be medium. 2, 3, 4, 5, 6, 7, 8. Okay. Hmm. These are consecutive, and they're not top or bottom right boys. We don't have a 4 in them. Can this be blue? I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9. This cannot be blue, because if that were blue, they would not be the same region for both of these two. Can they be pink? Probably, right? 2, 3, 4, 5, 6, 7, 8, 9. Yes. Can it be both orange? Yeah, possibly. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's possible too. Okay. Oh. What else do we have? This value has to be a 1. Right? The only value that's not a bottom left boy for the rest of these cells, besides these, is a 1. So this has to be a 1 here. That eliminates 1 in the rest of the light region. So we know this cannot be 6 and 1 adding up to 7. So this can't be 7. That's 9, guaranteed. So no 9 there. So we have a value of 1 here, no 1 there. So one of these is a 1. Aha. One of these is a 1, which means this cannot be 1, 2, 3, 4. This is at minimum 2, 3, 4, 5, which adds up to 16 at least. Okay, so that's 7 or 9. This can't be 9 anymore. You cannot have 2 and 3 here. So if you had a 1 here, the problem is this set would be at least 2, 4, 5, 6. Because this is 2 or 3 here. 2, 4, 5, 6 adds up to at least 17. And that would invalidate that. So this cannot be a 1 here, which means this has to be a 1 here. So this is the same as B. So we have B there. We have to have a 1 somewhere here. It cannot be 1, 2, 3, 4, adding up to 5 doubled, which would be 10. It can't. It could be 1, 2, 4, 5, adding up to 6 doubled, which is 12. But we know B has to be 2, 3, 4, or 5. So if this were 1, 2, 4, 5, adding up to 6, we'd have these be, that would eliminate 2 here, that's 3, but that would eliminate 1 through 5 here for the B. And that's not going to work then. So this must be 7 doubled. And this has to be, again, a 2, 3, 4, or 5. That means we have a guarantee. This is 7 double. That's 6. That's 14. That means we have to have either, to add up to 14, so 1, 2, cannot be 1, 2, 3, 8, because that would eliminate all possibilities for that cell there. So this is 7 doubled, which means this must be 9 doubled there. Because we can't have repeats in the top right, boys. 1, 2, 3, 8 doesn't work because of that would eliminate all possibilities for that cell there. So this has to have 1 and 6 then. Because otherwise, if it doesn't have 1 and 6, it would eliminate both of these possibilities here. Which means where's 8 in column 1, it has to be here. So that's 8. That eliminates 8 in the rest of the region. We do not have, so 1 and 6 already adds up to 7. So we need another 7 to add up to 7 doubled. So it's either 2, 5 or 3, 4 here. We're guaranteed a 2 or 3 here. This is 2 or 3. That eliminates 2 or 3 in the rest of the column. So this is 4 or 5, which matches B. So this must be 4 or 5. Okay. What else do we have? A is not 8. This is guaranteed to be 1 and guaranteed to be 6. The remaining digits in the red region then have to be 1 out of 2 or 3 and 8 and 9. With 8 and 9 guaranteed to be in one of these 2 cells or one of these 3 cells in column 2. That means these can't be 8 or 9. So we need a 9 here in column 3. 8 is already here for the green. But there's no other place for 9 in the green region except for here in column 3. That means this can't be 9. This can't be 8. So 8 has to be one of these 3 here for the light region. Okay. 1 eliminates 1 here. Whereas 1 in the green region, it has to be here. Can't be here because of 1 in the row, so the 1 has to be one of these 2 cells there. Okay. This adds up to 18 without a 1, and you cannot have 4 and 5. These digits are consecutive in value, but they could be a top right boy. Okay. Let's continue with this. 4 digits unique that add up to 19. Or, sorry, 18. Without a 1 and no 4, 5. 2, 3. Obviously no 9 either. 2, 3 is 5. It cannot be 2, 3, 4, 9. 2, 3, 5, 8. 2, 3, 6, 7. Both work. Huh. 2, 3, 5, 8, 2, 3, 4, 7. These are not top left boys. Or top right boys. This could be. If you have blue, blue, that could be a top left boy. 9 cannot be here. Oh, that's interesting. Where's the 9 in the blue region? It can't be here. So it would have to be one of these two or one of these cells here. Oh, 9 eliminates 9 here. Okay, yeah, where is 9 in row 9? Can't be here because of the yellow region, so 9 has to be there. So no more 9s here. 8 has to be one of these cells here. Can we have 8 here? Yes, 2, 3, 5, 8, right? Okay. A cannot be 8 here. So we have a guaranteed 8 in one of these 5 cells. So either this is 8 or this is just like 2, 3, 5, 8 or something along those lines. That's interesting. 1 is here. So 1 has to be one of those two. We have 9 here. Okay. This can't be 8. It's the same as that digit. Therefore, because there's already an 8 in the green region, this can't be 8. So what happens if this is not 8? How many versions does 8 have with 9? Or to add up to 18? 18 minus 8 is 10. So 3 other unique digits has to be... Okay, we also know 9 has to be one of these 3 cells here. We need a 9 in the dark region. It can't be any of these cells. It has to be one of these 3. Okay. Medium region has the same issue, right? We have to have a 9. It cannot be any of these. So 9 has to be one of these 6, but without this one here. So one of these 5 cells is a 9. None of those can be 9. If this is 8, the remaining digits must add up to 18 minus 8, which is 10. That's 3 digits adding up to 10. without a 1. And without a 1, it's only 2, 3, 5. So either this is going to be 8, or this is 2, 3, 5, 8 here, and this must be then 6 or 7. So this is 6, 7, or 8 there. What are the other possibilities to add up to? So we have it with 8. What about 7s? If you have 7, it could be 2, 3, 2, 3, 6, 7 adds up to 18. Or 2, 4, 5, 7 adds up to 18. But that's not possible because this must be 4 or 5 here. Or, no, 7 plus 3 as a minimum doesn't work. So we have, the possibilities are, this is 2, 3, 2, 3, 5, 8, or 2, 3, 6, 7 so far. Are there any others that add up to 18? What about 2, 4? 2, 4 gives us 12, so that means it has to be 5 and 7. But that would eliminate all possibilities for this. And then obviously 2, 4, 6, 6 doesn't work. And 2, 5 doesn't work then either. So this is guaranteed to be 2, 3 with either 5, 8 or 6, 7. So if this is 5, 8, this is 6, 7, 6, 7. If this is 2, 3, 6, 7, this is 8, and this has to be 4, 5. Okay. So this has to be 4, 5, or 4, 5, 6, or 7 there. Okay. If you have 2, 3, 5, 8 here, this again becomes 4. This is 6, 7, 6, 7. So this would be 6, 7. This would be 4, so that would be 3 and 4 here, so that would be 6. Oh, interesting. So what does that mean? Okay, so if this is 2, 3, 5, 8, we have 6, 7, 6, 7 here. This would obviously be 6, 7. And then we'd have 4 here, which means this is not 1, 2, 1, 3, 4, 6. It's 1, 2, 5, 6. Which means that's 3, which makes that 6. So then this would be 7. That would be 7, and this would be 6. Or this could be 8, and this is 4, 5. So this is 4, 5, or 7 here. Interesting. Wait, 8 could be here also. No, because medium needs an 8. Okay, yeah. I don't know if I articulated that idea, but yeah, medium has to have an 8 in one of these cells because 8 cannot be here for that region, and this region can't go below this line here because this is the bottom left. This is the bottommost row here for the medium region. So 8 has to be one of these 4 here, which eliminates 8 from being any of these cells here. So for light, you can't have 8 in any of these cells. You can't have 8 in any of these cells. Where is 8 in column 3? Can't be in the green region. This is 1. Can't be in any of these cells because we have a guaranteed 8 here and an 8 here. And this can't be 8 because of 8 in the row. So 8 has to be here. So this is 8, which makes that 4. Now that's interesting. That means there's no more 4 in the A region. So this is 5 or 7 no matter what. So where's 4 in row 9? It has to be here. So this is guaranteed to be 4. That's the same as B here, so that's 4. This cannot be 1, 3, 4, 6. So it has to be 1, 2, 5, 6 here. That eliminates 1, 2, 5, 6 in the rest of the column. No 2 here. That's 3. This is 6. No 6. Well, we already knew that. This cannot be 2 anymore. It's 3, 8 as a pair. Interesting. Remaining digits of row. Column 2. We have 1, 2, 4. Well, okay, 4 cannot be in any of the greens. So where's 4? It has to be there. So this is 4 there. Then we have 1, 2, and then 5 and 7 left. This can't be 1, obviously. No 7 there because of 7 in the row. This forms a 1, 2, 5, 7 quadruplet in the green region, so the remaining digits then there must be, what, 3, 6, and 9? And no 9 here because of 9 in the row. Okay. That means this can't be 6 here. This is 7. So this dark has to be either 6, 8, or it can't be 8. Because we have 8 in the dark region. It's 6 or 9. Because we have we have 1, 2, 3, 4, 5, 7, 8 accounted for in the dark region. So there's going to be a 6 here also. Actually, that's not true necessarily. This can't be 6, 3, 6, and 9. So that leaves a 2 and a 5 remaining in the light region. So this can't be 8 here. Remaining digits in the light region are possibly 7. Oh, and this can't be 7 here for the light region. So we have to have 7 here. And this could be a 6 of the light region. We just don't know which one. It's either that one or it's that one. If it's light, but we don't know. 7 eliminates 7 here. 7 eliminates 7 in the column. So the A has to be 5. So these are 5. That means this cannot be 2, 3, 5, and 8. It's 2, 3, 6, 7, adding up to 18, which means this can't be 6. That's 8. So there's no 8 here. 8 has to be one of those 3. That's fine. Remaining digits in column 4 are 2, 3, 6, 8, and 9. No 8 here because of 8 in the row. No 9 here because of 9 in the row. Okay. So we have 2, 3, 6, 7 in the yellow region. The remaining digit now is a 4 for the yellow region. So these 3 digits add up to 18 minus 4, which is 14. Not that many restrictions, though, unfortunately. Let's see. Really, we just have this information and these pairs. So these are well, we have to have an odd digit there. So it's 1, 3, 5, or 7. There's no 7 in either of these, so because of the 7's in the row. Oh, this is 5, which means this can't be 5. That's 2. This can't be 2 or 5. It's 1, which makes that 7. So that's helpful. No 1's here. So no ones, no sevens here. This is 3 or 5. 3 cannot be with 4. It could be with 2 or 1 doubled. But we already have ones in this row. So this, if it's 3, it has to be with 2 here. So it cannot be 2 here. Therefore, 2 has to be here if that's 2 and 3. So then this, it could be 2 doubled with 3. No, it can't. It'd have to be 2 is a singleton, or not a doubled, with 3 because they're in the same region. And if they are in the same region, there's no way this is a top right boy. 5, it cannot be 9 because of 9 in the column. Can't be 7 because of 7s in the rows. Can't be 1 because of 1 in the row. 5 cannot be with 4. And it can't be with 2 doubled because these have to be in the same region. So there's no way that this could be 2 doubled. You could have a 3 doubled, though. And it would have to be the top part, if that's the case. Or you could have a 6 here to be consecutive. That's interesting. Okay. Oh, we have 2 4s here. That's really bad. That's not going to work. This is a top left boy, but that's not, or top right boy, but that's not helpful. Dang it. This is horrible. No. Dang it. I think, yeah, it still has to be that way. Oh. No, 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 no. Okay. Shoot. The logic is all sound. But then we lead to a contradiction. Oh. Oh, this can't be 4. So since this can't be 4, this has to be 4. Yeah, I think this 8 still checks out. I don't know why I removed the 4 here. I don't know if that's gonna work. 8 and 4. We can't have an 8 be either of these. We have to have an 8 here in the medium gray. We need a 4 in the light region now. Interesting. So 4 cannot be here. That means this has to be a 4. So that's 4 there, which makes that 5 and 5. So this cannot be 2 and 5. It's 1, 3, 4, 6. Okay, yeah, I don't... That makes this 2 and 7. Makes that 6. Light needs a 4, and it cannot be here. So then this must be light. So it's not orange, this is light, and is 4. Okay. So we don't have any darks here. So dark has to go that way, because we're done with lights. This can't be dark. No dark here. Huh. So then this has to be 9. This is 4 and 5, so it's not 5, 8. It's 2, 3, 6, 7. This is freaky. Okay, so this is 8. Does this work? Ooh. No 3 here. It's 2, 8 as a pair. This can't be 8. No 4 there. 8's there. Remaining digits are 1, 3, 5, and 6. No 1 here because of 1 in the row. Huh. No, we have 2 4s. That's problematic also. It's really this 8 that's causing all sorts of problems. Okay. 8. Yeah, the medium needs access to an 8 somewhere. And it's going to have to be one of these. Orange does have to go out this way. This can't be 8 here. No 8 here. No 8 here. This is a bottom. It has to match one of these two. And this is 1, and we can't have 1 be there. So that forces this to be 1. Ugh. This is not good. Not good at all. 8 is only in a 1 to 2 ratio with 4. Ish, ish, ish. That's how we eliminated that. That's why it was 8 and 4. What am I doing wrong here? Yeah, this is very hard just because of the execution here. You can it's so easy to mess something up, right? Ugh. Maybe I think this logic makes sense, right? This has to be a top right boy, so it has to be it has to be in the top row. And there's anything else in the same row with it would be the other top would be top right boy then if that were the case. And it has so you have to have you can't go here. These are definitely bottom left boys. Same with all of these. And again, we show that 1 out of these 3 is going to not be a bottom left boy. Excuse me. So red is going to have cells, so it has to be there. Green has to go here. That works. This has to be a top right boy for the same reasoning. So it cannot go up here for this region, so it must go that way. So then this has to go that way. This has to go that way. This has to go that way. This can only go up. So I think all that logic checks out. We can't have 8 doubled here. We can't have 8 be any of these cells here. B matches B there. A matches A. So this has to be 8. And that eliminates 8 from the medium region here, so medium has to have 8 there. Which means this must be 8, so this this cannot be 8 here. Can't have 8 here because of 8 in the row. 8 can't be here because of 8 in the row. 8 can't be here because of 8 in the region, and this is a 1. So we're forced to have this is 8 and this is 4, but then there's no possibility for 4 in column 2 then anymore. Dang it. That's horrible. Obviously, we're messing something up. So the question is, what are we messing up here? Pretty sure all my logic checks out. Yeah, the problem is that this has to be 8 then. And this is not a top right boy. This is the top right boy. Oh, that's another thing we should notice. So that's a top right boy. Oh, it can't even be 7 here. So that's problematic in itself. Uh. Oh, this can't. Okay. Well, that's another thing that we know. This can't. One of these is going to have to be top right boy. And if this is top right. So. Shoot. Oh. I messed that up. Okay. That's where I messed up. One of these is going to have to be top right boy, right? And the problem, and I messed this up. This is going to have to be top right boy here. Okay. Well, let's retract that now. Let's change. That's bad. Okay. All of this logic was correct. Even this logic is correct. This does have to be 1. So this can't be 1. But if this is top left boy, it's going to be 6 or at least doubled, which is going to be greater than that. So this cannot be top right boy here. Therefore, this is dark, which means these can't be dark here. These are both medium. So dark is done as a region. And this is, we don't know what this is. This is not 1, 2, or 3 anymore. It could be 6 doubled, it could be 7 doubled, or 9 doubled. So this is a top right boy. That's where I messed up. So light has to go to here. So this cannot be orange. It's light there. This is top right boy for there. So top left boy is, or bottom left boy is there. Top right boy is there. Top right boy is there. Bottom left boy is here. Bottom left, top right. So this is top right boy there. One out of orange or pink is going to have to be here. We don't know which. So this is 1, which means we have to have one of these be 1 here. So no 1 here. So one of these is 1, the other one is 2, 3, 4, 5. Okay. So this cannot be 1, 2, 3, 4, adding up to 5 there. This could be 6, 7, or 9 here. So this is 6, 7, or 9 there. 6. That was a pretty bad mistake. Anyways, 4 cannot be any of these digits here. 6 doubled, 12. Could be 5 and 7. Or 3 and 9. 7 doubled. It cannot be 9 doubled. So this cannot be 9 doubled, because if it were... So therefore 9 is one of these two. Because 9 doubled is 18, which 2 digits are never going to add up to. Because they're both see the 9 here. So this cannot be 9 here. It's 6 or 7. So 6 doubled is either 3 and 9 or 5 and 7. 7 doubled is 14. So this is either 6 here and that's 8. Or this is 7 and... Sorry, 7 doubled is 6 and 8 or 9 and 5. So this is 3, 5, or 8 here. Interesting. Okay, that changes quite a bit. Again, this cannot be... This is guaranteed to have a 1 in one of these two. So these two cells are the same as these two cells. Oh. Well, then this is the same as that. So this is 6, 7, or 9. This is 1 through 5 here. We're not sure which. These two are the same. You could have 9 doubled there. What does this add up to? 6 doubled would be 12, but it would have to be 1, 2, 4, 5 because we'd have a guaranteed 6 there. So that doesn't work. Yeah, so this can't... I don't think this can be doubled 6. Because again, if this is 6, you don't have a 6 available for this arrow. So that would be 1, 2, 4, 5. Guaranteed. But that would eliminate too many possibilities for these two cells. So this cannot be 6. What about 7? Well, without a 1, I think it's the same problem, right? 7 doubled is going to be... you cannot have 5 here. Ah, well, that's kind of helpful. You cannot have 5 here because that would be 1, 2, 3, 4 guaranteed here to add up to 10, which is 5 doubled. But then that would eliminate all possibilities for this cell there. So this is 6, 7, 9 as a triplet in the top right boys. So that means these have to be 1 through 5 there. That's interestingly enough. 4 can't be here. So 4 has to be one of these 4 cells. Again, can this be 7 doubled? That's 14, and we cannot have a 1 here. We can't have 2, 3, 4, and 5 here either. Right? Because 2, 3, 4, 5 would eliminate too many possibilities for these two cells here. We'd have 6 cells trying to contain the digits 1 through 5. And there's no other way to add up to 14 without a 1 for 4 digits except 2, 3, 4, 5. So this can't be 7. This is guaranteed to be 9. So that means this cannot be 9 here. We have a 6, 7 pair remaining in column 1. So this cannot be 6, 7. Okay. Interesting. 7, so 7 doubled is 14. 6 doubled is 12. Anytime you have a 9 with 1, 2, or 3, at minimum it adds up to 15, which is greater than 6 doubled or 7 doubled. So this has to be a 9 there. Okay, so that changes a lot. That eliminates 9 from this. Oh, no, this has to be 9 because this is 9 now, right? So this has to be 9 there. So that's helpful. That means this cannot be 9 here. These are 6, 7 as a pair. That forces this to be 9 there. Light needs access to a 9. Cannot be here. Cannot be here because of 9's in the column. So it has to be one of these two. So one of those two is a 9. We don't know which. Hmm. Okay, so if this is 6 doubled, that's 7 and that's 5. If this is 7 doubled, this is 6 and that's 8. So those are the only possibilities. Again, if this is 6 doubled, that's 7, this is 5. We would have to have 7 doubled here. Okay. Hmm. So these have to be 5, 6, 7, or 8. They must correspond to these two digits here, because there's no other place for it in the red region. So this could be 8 now. So we don't have that much information there. So this is the same as that. So let's mark that as Z, I guess. Z needs to be somewhere in the medium region, so it's here. Z cannot be here, so Z has to be one of these two. Z then has to be one of these 4, because it can't be in the green region here. We have, this is Y. Y has to be the same as that. So Y can't be here, so Y has to be one of these 4 also. Right. So where's Y cannot be any of these. Z cannot be any of these because this is in the same region. So this cannot be 6, which means this can't be 3 then correspondingly. Excuse me. We're guaranteed a Z here. Y can't be here, but Y could be any of these. Y cannot be here anymore. So Y has to be one of these 4. Okay. So if this is 6 doubled, this must be 7 doubled, which is 14. So if this is 6 doubled, that's 7 and 5 adding up to 6 doubled. That's 12. 7 doubles 14. It has to be 1, 2, 3, and 8 because there's no other place for 8 in column 1 because this is the same as the 1 or this B here. So this would be, in that case, 1, 2, 3, 8. So this would be 4 in that case. Otherwise, this is 6 doubled. Oh, so this can't be 1 either way. If this is 6 doubled, 4 digits adding up to 12 would be 1, 2, 3, 6 or 1, 2, 4, 5. So this guaranteed cannot be 1 or 2. So this is 3, 4, 5, which means 1 cannot be here. Therefore, where's the 1? In the bottom left, boys, it has to be there. So if this is 6 doubled, this is 7 doubled, this is 6 and 8. It's either 1, 2, 4, 5. It cannot be 1, 2, 3, 6. So in that case, this would be 1, 2, 4, 5. And this would have to be 3. So this is 3 or 4. And that matches this. Right, to add up to 14, we don't have an 8 anywhere else in column 1, so this would have to have an 8. 8, 1, 2, 3 adds up to 14, which is 7 doubled. If this is 6 doubled, obviously you can't have 1, 2, 3, 6 anymore in the column, so it's 1, 2, 4, 5. That makes this 8 and 6, and then this is 3. Okay. So this is 3 or 4 to correspond to that cell there. Yeah, I don't know. Do we make this X? I don't know. X and X, A and A. This is B and... Oh, this is the same as... Okay, B. All right, so this is B. That's B. Okay. These cannot be 6 or 7. So we have no 1. This can't be 1 because of 1 in the column. No 9. So we have 2, 3, 4, 5, 8. No 4 here because of 4 in the row. Okay, so where are 6 and 7 here? 9 has to be one of these two. 6 or 7 for the Y has to be one of these two. That means this cannot be, this is not 4. So this has to be 9 and Y here. Well, where is Z? Z can't be either of these now. So Z has to be here. So this is Z. Wait, that doesn't work. This is Z. Wait, that doesn't work. Shoot. What? Oh, no, we already have Z. Sorry. We have Z in this region. Okay. So then Y does have to be there. Then this cannot be 4. This is 9 and the other 6, 7. That means this is 2, 3, 4, 5, 8. This can't be 4 again because of 4 in the row. So 4 has to be one of these two digits, which means this can't be 4 here. Since this can't be 4, this can't be 2 or 8. So this is 3 or 4 here. That's interesting. It doesn't necessarily have to be the same one. So we know 4 is one of these two. Cannot be here. So 4 in the green region has to be one of these 4. Hmm. So the problem is this 3, 4 is very different than the 4, 5 that we had as possibilities. Huh. Oh, this is Y also, and this is Y, Z. So Y and Z both see this cell because they're in the same region, so this is 9. This is no longer 9, this is Y. So we have 9 there. Which means 9 as the bottom left boy has to be one of these two. Okay. Hmm. Okay. Excuse me. To add up to 18 for 4 digits without a 1. Okay. 2, 3, 5, 8, 2, 3, 6, 7 both work. We cannot have 3, 4, 5, 6. So we're guaranteed a 2 has to be one of those 4. But 2, 4, 5, 7 now does work. Oh, we have Y and Z here. So this cannot be 6 or 7. Interesting. So no 2. It could be 3, 4. It could be 5 or 8. So 1 out of 6 or 7 has to be here. So this cannot be 2, 3, 5, 8. It's 2, 3, 6, 7 or 2, 4, 5, 7. So we're guaranteed a 7 here, right? Because we have both 6, 7 pairs here. Let's just do remaining digits in column 4. We have 2, 3, 4, 5, 8, and 9. Obviously, these can't be 9 because of 9's in the rows. So this has to be 3, 4, 5, or 8. That would correspond with A. Excuse me. We have Z, Y. Let's make this X, I guess. So this is a XZ pair there. X also cannot be here because of X in the region. So X is guaranteed to be one of those 4. So this is either 2, 7, 3, 6, or 4, 5. So we're guaranteed a 3 or 4 here then, right? Because it can't be 3, 4, 5, 6, which is the largest minimum digit for having to add up to 18. 3 with 4, 5, and 6. So we're guaranteed 2 here. We can't have 2, 8. Because that would be 3 and 5. Right, and because we don't have 2 possibilities for 6 and 7 here. So this would have to be 3 or 4. 2, 7, 3, 6, or 2, 7, 4, 5 here. Because we don't have the 8 available here, because again, 2, 3, 5, 8 doesn't work, because that would eliminate, we would have no places for the 6 and the 7 in row 9. Because of this ZY pair here. This can't be Y, because we have a Y in the row. Okay. So we have a guaranteed 3 or 4 here. We have a guaranteed 3 or 4 here. That eliminates 3, 4 in the rest of the row, so no 3, 4. We have 2 and 7 there. So this could be 5 or 8 or 6 here. We don't know. So this is 5 or 8. So no 4 here. Is this the same as X? Maybe. No. No, it cannot be. So this is the opposite of X. Interesting. So this is A is 5 or 8. Z, X is 5 or 8. That means this can't be 5 or 8 in the remaining digits in the column. So this can't be 5 or 8 either. It's 2 or 3. Remaining digits, yeah, we have a 5, 6, 7, 8 quadruplet in column 2, which eliminates 5, 6, 7, 8 in the rest of the column. So we're left with 1 through 4 here. 1 can't be here because of 1 in the row. So we know 1 does have to be one of these two. Excuse me. We have a guaranteed 9 in one of these cells, but it can't be here, so 9 has to be one of these 3. Okay, that's much better. Um, hmm. So X has to be one of these. Really, one of these 4. Excuse me. A has to be one of these 4. Cannot be here. So this is not 5 or 8. A has to be one of those 3. A is here. A has to be one of these 3. It's 5 or 8, so it's one of those 2, really, because this can't be 5 or 8. X is one of these. We don't know which. Okay. Hmm. Oh, that's interesting. Oh, never mind. Okay, never mind. I was thinking of something else. No, that is interesting. Okay. Y. Where can Y be in row 3? Can't be here because of Y in the column. Can't be here because the Y in the region is here. Can't be here because Y in the column. It can't be in the medium because Y for row 2 has to be in the medium region. So it has to be the orange region here or the pink. But Y cannot be a top right boy. So Y can't be here guaranteed. Y has to be one of these 2. And if it is one of these 2, it has to be orange. So I don't think pink can ever get here. Right? Because Y cannot be the top right boy, so it has to have another digit, which is top right of most of that. If we have pink here, the problem is where would the Y be? Pink can only go so far 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the problem is orange would go here. But the problem is neither of these could be 6, 7 because they would be top right boys. Or the Y 6 and 7, I should say. So Y has to be either here with orange being there. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is possible. Not completely. One of these has to be medium. So it could be Y and then top right boy, or Y and then top right boy. So one of these 2 is top right boy. This cannot be pink. So one of these 2 is top right boy. We don't know which. Let's mark it as green for now, for that it's not circled, because we don't know for certain. Hmm. This has to be orange because it's no other place. This has to be pink because there's no other place for it to go. So blue has to go this way. 1, 2, 3, 4, 5, 6, 7. It has to go this way at least. Cannot go blue, blue because these are the same region. So this is guaranteed to be blue. We can't go pink that way because that would be too many cells. Or that would be not enough cells for blue and too many cells for pink. 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to get there. So this can't be pink. Therefore, this is all blue. Okay. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9. This is top right boy here. This has to be not orange, not blue. Sorry, not orange, not blue. No blue. 1, 2, 3, 4, 5, 6. So this has to go that way. No pink here. It's orange. That means this has to be orange there. No pink. Okay, boundary, boundary. 1, 2, 3, 4, 5, 6, 7. So no orange, it's pink. These are part of the same region, so this has to be both pink. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are all, and it cannot go up this way as I showed before. It can't even now. So that's obviously problematic. So then these are both pink, which means we have orange there. And this is top right boy. So this is doubled, which means this must be an odd digit. So we have 1, 3, 5, 7. 1 doesn't work because 1 is only consecutive with 1 doubled. So 3, 5, 7. 3 could go to 2 doubled or 4, 3 doubled. That is, no, 2 doubled. Cannot be 1 because of 1 in the row. 5 could get to 2 doubled or 3 doubled. 7 could get to 6 or 8, which is 3 doubled or 4 doubled, but we can't have 4 because of 4 in the column. So now we have a 2, 3, 4 triplet in row 4, which eliminates 2, 3, 4 in the rest of the row. So that means this is 5 through 8. So one of these is 6, 7. Okay, one of these is 6, 7. It's the y 6, 7 because there's no other place for y to be except in the orange region. So that means the rest of orange cannot contain 6 or 7. Or 5 or 8, because we are guaranteed 5 and 8 here. So that means the remaining digits of orange region are 1, 2, 3, 4, and 9. No 9 here, no 9 here. We have to have a top right boy in one of these. We have 1, 2, 3, 4, 2, 3, a 4. Oh, 4 means this can't be a top right boy there as a 4. Top right boy here, we have 6, 7, 8, 9 accounted for, and 4. So it's 1, 2, 3, and 5. It cannot be a 5 here for the top right boy for the orange region because the 5 already is accounted for. So the top, so this is 6, 7. So this has to be orange here because it's either orange that way or orange that way. Because we need a top right boy and the y 6, 7 here. So this is guaranteed not to be medium. So this is 1, 2, 3, or 6, 7. It's the y or it's a top right boy. We don't know which. And where is the 5 for the top right boy in the blue, in the top right boys? It has to be here, right? Because it can't be here. Because we have X here and A here, and one of those two is 5. Can't be here because this doesn't add up to a digit when doubled, unless it's 2 or 3. And everything else is accounted for. So this is 5 here. That eliminates 5 in the rest of the blue region. That means this can't be 5. Interesting. So we're guaranteed one of these is a 3, right? Because it's either 3 here, which would be consecutive with only 2 doubled, or it's 7 here, which is only consecutive with 3 doubled. So 3 is one of these two, which eliminates 3 in the rest of the pink region. Okay, so we have these. We have 6 digits here, which must add up to 9 doubled times 2 minus a 3 or a 4. Okay. What is that? So what's the most we can have here? Well, we're guaranteed one of these is a 9. So 9876. That's a lot. 37 for 6 digits. 9876 4 and 3. Okay, remaining digits in column 9. We have 1, 2, 3, 6, 7. And this can't be 3. 1, 2, 3, 6, 7. No 3. 1, 2, 3, 6, 7. No 1. Okay. Uh, hmm. If this is 3, what happens? If this is 3, that makes that 2. That's 2 doubled. So that's 3 there. Okay, so this can't be 3 either. I forgot about that. This can't be 1. So this is 2, 7 with either 3, 6, or 4, 5. If this is 3, this becomes 6. And we have 2 there. So this becomes 2 and 3. So no 3 in either of these spots. These are 3s in the row. No 3 here, so 3 would have to be there. No 2 or 3. It's 4, 5, 8. This is 5, 8 as a pair. That would force this to be 4. No 3 or 4 there. No 3 here. We have 1 as a top right boy somewhere. One could be adding up with 8 and 9 to add up to 18. No 2 and 3 here. That becomes 4. So that leaves that as 1. No 1 or 3 here. No 1 or 3 here. We have 2, 5, 8 there. That seems okay. was hoping that would lead to a quick contradiction. Hmm. Interesting thing is 5 in row 8 cannot be here, cannot be here. It has to be one of these two. I mean, I guess. Consecutive digits here. We have 1, 2, 3, 5, 6, 7, 8, 9. No 9 here. That doesn't help us any. Oh. No, this could be 1. Okay. We know we have 1, 2, 3 remaining in the top right boys. That, aside from these two, right? So either this is 1 with 2 or 3 here. And that's the other 2, 3. Or this is 1 with 2 or 3 here and 2 or 3 here. So this cannot ever be 1 remaining in... That's not the top right boy here and not the top right boy there. Okay. Right, so we just have top right boy here. Okay, this can't be 4 because of 4 in the gray region, in the medium gray region. This can only be the Y67 and the top right boy in the orange region, which is only 1, 2, or 3. So 4 can't be here in the orange region either. So where is, and this can't be 4 because we already have a 4 as a top right boy. So where is 4 in row 3? It has to be here, which does force us to be 3, and that makes that 2, and that makes that 6. Okay, well, there we go. 3 eliminates 3 here, so that's 2 and 3. 2 and 3 eliminate 2 and 3 there. It's 4. 2 and 3 eliminate 2 and 3 in the rest of the column and the rest of the region. This can't be... this is not 2. This can't be 4. This can't be 2. So it's 1, 3 as a pair here. And 3 eliminates 3 there, so that's 1, which makes that 3, which means we have a 1 in one of those two cells. That eliminates 3 in the rest of the row. This can't be 2 or 3. It's 5, 8 as a pair. This is A then. That eliminates 5, 8 in the rest of the row because of the 5, 8 pair. No 2 either, so we are left with 1, 3, 6, 7, 9 as the remaining digits. 3 eliminates 3 in the rest of the row. No 3 here. No 2. Could be 2. No, it can't be 2. This is either 1 or it's 6, 7 for the orange. Interesting. Okay, what can be consecutive here? 1 with 2, 2 with 3, 5 and 6, 6 and 7, 6 and 7, 7 and 8, 8 and 9. So all of those are still valid. Great. Lovely. We have 1, 6, or 7 there, 6 or 7 there. Remaining digits here are 2, 5, 6, 7, 8. No 6 here, though. 2, 5, 7, 8. We don't know which one's which. 6 is here, which means this y is not 6. So y is 7. So we'll move those. So these are 7. That means z is 6. So z is 6. 6 doubles 12, which is equal to 5 plus 7. X is 5. And A is 8. So this is 8 there. Where is 5 again in row 8? It has to be, can't be here because of 5 in the region, can't be here because it must match that B. So 5 has to be here. So that leaves 5 and not 5 here. 2, 7 as a pair. No 7, 8 here. It's 5, 6 as a pair, which is X and Z. 5 and 6. This has to have an 8. So it's 1, 2, 3, and 8 here, adding up to 14, which is 7 doubled. That eliminates 1, 2, 3, 8 in the rest of the column. So this is not 3, it's 4. That means this is 4 also as a B. This cannot have a 4 anymore. So we don't have 2, 3, 4, 5. It's 2, 3, 6, 7, adding up to 18 here. That means no 6 or 8 here. It's 5. 8 eliminates 8 in the rest of the column. This is B, must be a 4. That eliminates 4 in the rest of the column. Okay. No more 7s here. It's 5, 6, 8 as a triplet. That eliminates 6 in the orange region, so that's 1 or 7. No more 6s in row 2. So we have a 1, 3, 7, 9 quadruplet, which eliminates 1, 3, 7, 9 in the medium gray region. So this can't be 7. And these are all odd digits, which is only consecutive with an even digit here. So this can't be 5. Let's remove the... So 1 is guaranteed to be one of those two. 7 is one of these 3. Remaining digits in gray are 2, 6, or 8, and 5. So this could be 7 with 2, 5, 6, or 8. 5 eliminates 5 here. This can't be 4 anymore. No more 5 because of 5 in the column. No more 1 here because of 1 in the row. No 1 or 3 here because of 1 and 3 in the row. Where is 5 in row 5? It has to be one of these two. That eliminates 5. That guarantees a 5 in the pink region, which eliminates 5 in the rest of the pink region. So this is 9. No 9 here because of 9 in the column. Then we have a 2, 3 pair in column 4, which eliminates 2 and 3 in the rest of the column. So no 2 or 3 here. It's 5. That means this can't be 5. Okay, we have a 9 here. Where is the 9 in the blue region then? Can't be here, can't be here, so it must be here. That eliminates 9 in the rest of the column. 9 plus 2 digits adding up to 9 adds up to 18. So this would be 1 and 8, 3 and 6, or 2 and 7. This is 4. So 18 minus 4 is 14 without a 9. Not sure what else we have restricted then. 5 eliminates 5 here, so this is 6 and 5. We have a 5. We have 5 in one of those 3, 5 in one of those 3, 5 in one of those 2. Okay. Remaining digits in row 8. We have 1, 2, 3, 6, and 7. Well, if this were not 6 or 7 here, we would have to have a 6-7 pair. Well, that's possible. Never mind. I was thinking this adds up to 18, but it doesn't. Excuse me. We need a 4. We have a 4 missing in blue. Cannot be here because of the way that this adds up to the arrow here. Can't be here because of 4 in the row. So 4 has to be here. So where is the 4 in row 5? Can't be here because of 4 in the column. Can't be here because of 4 in the column. So 4 is guaranteed to be here, which eliminates 4 in the rest of the orange region. Also, we know this is guaranteed to be 1. That eliminates 1 in the rest of the orange region for the what is it called? Top right boy. So we now have a 2-3 pair here, which eliminates 2 and 3 in the rest of the region and in the rest of the row. So this can't be 2 or 3, it's 4. This can't be 2 or 4, it's 9. That means no more 9 there. 2 and 3 eliminate 2 there, so it's 7, which makes that 2. That means this can't be 2 here. No 3 here because of the 2-3 pair in the row. 2 eliminates 2, 7 as a possibility. So this is 4 and 4, which is 8. 18 minus 8 is 10. So these 2 remaining digits must add up to 10, and the only possibility there is 3 and 7. So that eliminates 3 and 7 in the rest of the region. No 3 here, that's 2. No 3 here, it's 8 and 1. That leaves this as a 6. 2 and 3 eliminate 2 and 3 here. It's 1, which makes that 8, which makes that 2, which makes that 3. 1 eliminates 1 from being here, so that can no longer be the top right boy. So this is not orange, it's medium, which means this can't be medium, it's orange, which means this is the top right boy here. And we are done as a region. So this is a 1, that's 7 now, to match this 7. So this can't be 7 here, it's 6. This can't be 6, it's 7. No more 7s here. 7 eliminates 7 here, so it's 3 and 7. No more 3 here. No more 3 or 7 here. 1 can't be here because of 1 in the column. No 1 here. Okay, we have 5 and 8 remaining in row 5. This can't be 8 here because of 8 in the column. So this is 5, that's 8. No 5 or 8 here, it's 6. That eliminates 6 in the rest of the row and column. 5 eliminates 5 here. We have a 2-3 pair in column 8, which eliminates 2 and 3 in the rest of the column. No 3 there. It's 7. That means this can't be 7 here. We have 1 or 3 here. That's not consecutive with 6 or 8. It's only consecutive with 2. So that's 2, which makes that 8. 2 eliminates 2 here. Remaining digits of row 6, we have 1 and 4. 4 can't be here because of 4 in the column. So this is 1, that's 4. 1 eliminates 1 here, so it's 9. No 9 here. No 1 or 3 here. 8 eliminates 8 here, so it's 5 and 8. 5 eliminates 5 here, so it's 2, which makes this 3. No 2 or 3 there, it's 1. No 1, 2, or 3 there, it's 5. 1 eliminates 1 here, so it's 3 and 1. 3 eliminates 3 here, so it's 2 and 3. 2 eliminates 2 here, so it's 6, which makes that 3, which makes that 2. And we are left with 6 and 7. And this can't be 6 because of 6 in the column, so that's 7 and 6 there. Choo-choo. I don't know what that means, but top right boy. Let's just double check. In the top right boys, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. In the bottom left boys, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Values of arrows. Actually, let's do croppy dots. 1 and 2 is in a 1 and 2 ratio, as consecutive, I should say. 3 and 2 doubled, which is 4 consecutive. 3 and 6 are in a 1 to 2 ratio. 4 doubled is 8, which is in a 1 to 2 ratio with 8 doubled, which is 16. Arrows. 0, 0, 0, 0, 0, 0, 0, 1. 0, 0 plus 15 is 16, which is 8 doubled. 5 and 7 is 12, which is 6 doubled. 1, 2, 3, and 8 adds up to 14, which is 7 doubled. 1, 8, 9 adds up to 18. So does 4, 4, 3, 7. And as does 3, 7, and 2, 6, adding up to 9 doubled. So there's the solution. Made that mistake there. That was a pretty bad error. I was trying to consciously keep the top right boy thing in my mind, but I just completely just forgot it there. I don't know why. Anyways, I hope you enjoyed that solve, and I'll see you next time on Frank Puzzles. Take care.